So today I will prove that if G is open subset of R set of real numbers, then characteristic function then the characteristic chi of G is continuous on whole G. That means if we are going to take any open set in R, open subset of R, then the characteristic function defined on that open set, that means since we know that characteristic function is defined like this, if x belongs to G and is 0 otherwise, that means if G is open subset of R, then we shall prove that this characteristic function of G is continuous on G. Okay? So in solution I can write, since we know that definition of characteristic function, that is chi G of x is equal to 1 if x belongs to this G and is 0 otherwise. That means for rest of the real numbers it is 0. So to prove the continuity of any function, we can make use of that sequential approach of continuity. That means we shall take any point from this open set. I can write let x belongs to this open set G. Since this is open, then there exists a sequence. Xn such that limit n approach to infinity xn is equal to n. That means I have taken this point such that there exists a sequence, corresponding sequence, which converges to that point. Sequential approach means if we have to discuss continuity at a point in a set, we are supposed to take any sequence which converges to that point, and we have to check the post images. Does those post images converge? Does the post image of this xn converge to post image of x? That means we will check that if xn converges to x, what about f of x and f of x? What about f of xn and f of x? Does f of xn converge to f of x or not? Since this is an arbitrary element of this, if we get success to prove that f of xn converges to f of x, then that means this characteristic function is continuous on each and every element of this open set. So now we shall check the post images of this characteristic function. Now let us check the post image of this sequence xn. Since xn is not a single term, it contains infinite number of terms, because every sequence contains infinite number of terms. If we are going to check the value of characteristic function in x1, it will turn out to be 1. If we are going to check like this, I am saying characteristic function of G x1 is 1, because this is why this is 1, because this sequence belongs to this G, because this sequence, that means each term of this belongs to this. That means whenever x belongs to G, characteristic function of x is always 1 at that moment. That means we can write it like this. This is 1, 1, so on. Right? That means we get a sequence 1, 1, 1, 1. What do you think? To which number it is going to converge? It converges to 1. Now we shall check out the post image of x. Now characteristic function of x. Since x is already in G, and whenever x is in G, this is 1. That means this will be 1. Can I say that this converges to this as an approach to infinity? Yes, because this converges to. That means I can write therefore chi g of xn converges to chi g of x as an approach to infinity. Right? So we get success in proving that the post images also converge. That means if xn converges to x, then chi g of xn converges to chi g of x as an approach to infinity. So by sequential approach of continuity, we can say that this characteristic function is continuous on this open set. So chi g is continuous on G, because this was an arbitrary element of this. Right? Thank you.